Okay, students, let's discuss equations of motions and graphical representation. Students, in this lecture, we will discuss about the equations of motion, uniformly accelerated motions, and the graphical representation of uniformly accelerated motion. Students, these are the equations of motion. V is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to twice as. These equations are applicable only for one particular type of motion, that's uniformly accelerated motions, and no other motion. Now let's understand these symbols. U is initial velocity. Initial velocity means the speed with which the body moves initially in the beginning. Now V is final velocity. At the end of the trip, the body may have a certain speed. So what is the final speed? What is the speed at the end of the trip? That's what the final velocity, final speed. And A is acceleration. Acceleration means at what rate the body's speed is changing. The body's speed is increasing or decreasing. That is acceleration A. And S is the distance or the displacement. How much the body covers the distance in certain time, that's is measured by a quantity called a displacement, and the t is the time for how long the body is in motion, that is measured by the time t. Now let's understand, student, one more important term, that is called a slope. Let's see what is slope. Student, I have a right triangle here. If I want to calculate the slope of a line, students, we calculate the slope of a line. Let's say suppose this line's slope, I want to calculate. Slope is the amount of inclination of the line with the horizontal. Students, remember, slope of a line is the amount of inclination with the horizontal, or we can say simply the amount of, or the angle made by the line with the horizontal. Say suppose this angle is making certain angle with the horizontal. This angle gives us the slope of this line. Say suppose I have two angles here. This is one line making an angle of 30 degree with the horizontal, and this is one line which is making an angle of 60 degree with the horizontal. So I'll say this line has a smaller slope and this line has a bigger slope. Now say suppose this is the horizontal line. Let's say suppose this is the horizontal line. If I want to know what is the slope of this line. Now students, see, this line is parallel to the horizontal. So this line will have a slope of a 0. And suppose if I want to know, a vertical line is there. If I want to know, suppose this is the vertical line, what is the slope of this vertical line? Now students, see how much is the angle made by this vertical line with the horizontal. Here is a horizontal. Now this angle is made by 90 degrees. So this line's slope is 90 degree. So I hope, student, you understood what is slope. Slope is the angle made by any line with the horizontal. Now if I want to calculate mathematically the slope of a line, how to calculate this? Say slope of a line AC. In this right angle triangle, if I want to calculate the slope of this line, I can do that by taking the ratio of the vertical to the horizontal, this perpendicular and this base. So slope of line AC is given by perpendicular BC and base AB. So the ratio of the perpendicular to the base in a right angle triangle gives us the slope of this line, the hypotenuse. So student, I hope you understood what is inclination or the slope of a line means. Now student, let's move on to describe different type of motions. Here we have 3 different type of motion. Let's see which motion is possible and which are not possible, and try and describe the motions graphically. Say student, here is one motion. We have a data provided here, distance 0, 5, 10, 15, 20, and time is 0, 1, 2, 3, 4. Students, don't get confused with the time 0. Time can never be 0. This is just a origin of a time. See, every measurement we make, and for that measurement we have a origin. Student, say suppose this 0, the home, the point, the place from where we start our measurement, that point can be considered as a 0. And the time from which we start our measurement of a time, that beginning time can be considered as a 0. Say suppose this is my home. So my home can be considered as a 0. From the home, I'll be measuring my distance. So that's why home can be considered as a 0. Let's say suppose I am starting my motion at 9 a.m. in the morning. So 9 a.m. can be considered as a 0. Let's say suppose this is 10, this is 11, and this is 12, and this is 1 p.m. 10 a.m., 11 a.m., 12 noon, and 1 p.m. So students, At 9 a.m., I was at my home, and suppose at 10 a.m., after 1 hour, I'm 5 kilometers away from my home, and at 11 a.m., I'm 10 kilometers away from my home, and at 12 noon, I'm 15 kilometers away from my home, and at 1 p.m., I'm 20 kilometers away from my home. I hope, student, you understood this situation. So now 0 for 0, 5, 1, 10, 2, 15, 3, and at 4, fourth hour, I'm at position 20. If we plot this graph, if we plot this motion graphically, we'll get the graph like this. Let's plot the distance along the vertical axis and plot the time along the horizontal axis. So 1, 2, 3, 4, and this 5, 10, 15, 20. So now start plotting 0, 0, 1 for 5, 2 for 10, 3 for 15, and 4 for 20. If I join all this set of points, I'll get a straight line. So remember, students, if a body moves uniformly, students, this motion is uniform motion. You can see in the first 1 hour, the distance covered is 5 km. Next 1 hour, the distance covered is 5 km. Next 1 hour, again the distance covered is 5 km. And the next 1 hour, again the distance covered is 5 km. That means every hour, the distance covered is same. So that's why this motion is uniform motion. So whenever you're drawing a graph, that is distance and time graph, for the uniform motion, you'll get a straight line inclined with the horizontal axis. Straight line passing through the origin inclined with the time axis. Now let's move on to another type of motion, student. Here we have a distance 5, 10, 15, 20, 25. Now initially, let's consider the time is at 9 a.m. This is 10, 11, 12, and this is suppose 1. Now student, initially I started my movement in this motion at 9 a.m. and I was at home. Now students, see, compare this. At 9 a.m. I started my movement. I started measuring my motion distance. But I'm not at home. I'm 5 kilometers away from the home. So now suppose at 9 a.m. I was 5 kilometers away from my home. At 10, I'm 10 kilometers away from my home. And at 11 a.m. I'm 15 kilometers away from my home. And at 12 noon, I'm 20 kilometers away from my home. And at 1 p.m., I'm 25 kilometers away from my home. Now students, see, this is 1 hour, this is second hour, this is third hour, and fourth hour. So again, in this example also, every hour the distance covered is 5 kilometers. So again, an example of a uniform motion. If I plot the graph for this motion, I'll get the graph again a straight line. Because the motion is uniform, so for every uniform motion, distance time graph will be a straight line. But compare these two graphs. Both this graph represents uniform motion, but the straight line position is different. Here in this case, straight line is passing through the origin, and in this case, the straight line is passing from the point 5. So I hope you can compare this, why this line is starting from origin and why this line is starting from 5. Because in this example, I was 5 kilometers away from my home. This is my home. This origin my home. I was 5 kilometers away from my home, and at that point I started my measurement. But in this example, I was at home when I started my motion, my measurement. So that's why this graph is different. The graph is passing through the origin, the graph is passing from 5.5. Student, now in this example, see, distance 20, 15, 10, 5, 0. In this example, the distance is decreasing as the time is passing. Students, compare a situation where you are traveling, and as the time passes, just ask yourself, with the passing time, the distance will increase or distance will decrease? Of course, the distance will increase. So here in this example, the distance is decreasing. So this type of motions in reality doesn't exist. So this motion is not possible, student. So student, here in this case, distance and time, vertical axis distance is plotted, and horizontal axis we have plot the time. D is proportional to T. Distance is directly proportional to time. Every time, students, you plot the graph for any two quantities which is directly proportional. Let's say suppose y is proportional to x. You will get the graph like this. Always y is vertical, x horizontal, and this line is your graph. So any two quantities which varies directly, if you plot the graph, you'll always get the graph straight line. Now slope of the dt graph always gives us the speed, student. Slope of the dt graph gives us the speed. Just a while ago, I mentioned here slope means. Now let's understand, student. Let's try and calculate the slope of this graph. In this graph, if I want to calculate the slope, I'll draw one right angle triangle. You can draw a right angle triangle of any size. You can draw this right angle triangle, consider this right angle triangle. You can also construct the right angle triangle, this small triangle, or the small triangle, or a small triangle. You can consider right angle triangle of any size. Let's consider this bigger triangle. Now slope means this angle, and you know how to calculate the slope. Slope for this line will be calculated by the ratio of this vertical and this horizontal. Now student, this vertical line gives us what? This vertical line length, the amount will be given by this vertical axis. From this vertical axis, what do you get? You get the distance, and a horizontal line, this horizontal line will give you the time. Now students, distance and times ratio is what? Distance and times ratio is the speed. So that's what I meant by slope of the distance time graph gives us speed or velocity. So now next, see here in this case also, if you calculate the slope, how will you calculate the slope? You construct one right angle triangle this way. Now you calculate the slope. If you calculate the slope, you take the ratio of this vertical and this horizontal. Vertical line and this horizontal line. That will give you the slope. And again, this time distance, this vertical line is the distance. The amount of this vertical line can be calculated from this vertical line. And this is the horizontal line. This is time. So distance by time is the speed. Let's move on, student. Let's understand speed time graph. The first graph that we discussed, that graph was between distance and time. Now we'll discuss another type of a graph, that's a speed time graph. Now before we discuss and understand the speed time graph, let's see these three situations are given to us. These three situations are there. So here speed, and this is the time. These are the speeds 0, 5, 10, 15, 20. These are the speeds. That means the body was initially at rest because speed is 0, and the body's speed has changed. Body started moving and the body gained the speed of a 5, then 10, 15, 20. That means the body's speed is increasing. As the time is passing, the body's speed is increasing. Here also you can compare this in the second situation. The body's speed is increasing 5, 10, 15, 20, 25. Here in this third case, the speed remains constant 5, 5, 5, 5. That means the body is in motion, but the body hasn't changed its speed. The body's speed is not increasing, not decreasing. The body is moving with a constant speed of a 5 km per hour, let's say. Now let's describe this situation, students. Let me just draw the graph for this motion. We'll plot the speed along the vertical axis and a time along the horizontal axis. See 0, 5, 10, 15, 20. We can write like this 5, 10, 15, 20. These are the speed. And 1, 2, 3, 4. This is horizontal axis time. Now students, if I plot this, I'll get the graph like this. I mentioned, a student, if any two quantities varies directly, uniformly, you'll always get the graph straight line. You'll always get the graph straight line. So here also you can see the speed is increasing. Speed is increasing. In the first, let's say, suppose 1 second. First 1 second, the speed has become 5. Next 1 second, the speed has become 10. Next 1 second, the speed has become 15. Next 1 second, the speed has become 20. The speed is increasing. But pay attention, student. At what rate the speed was increasing at every second? Every second. It was 5, 5, 5, 5. That means the speed was increasing, but the speed was increasing at constant rate of 5, 5, 5. So this is the graph representing this situation. Now student, let's understand another situations. Here we have speed and time 5, 10, 15, 20. Let's plot the speed along the vertical axis and time along the horizontal axis and try and draw the graph. You'll get the graph straight line like this. You compare this to graph. Initially the body was at rest. That's why our graph in this case is starting from the origin. But here the point from where we started our measurement, at that point the speed was not 0. That's why our graph has started from 0.5. So this is the straight line graph. Both these cases, the speed is increasing. That means the body is under acceleration. In this case also the body is accelerating. In this case also the body is accelerating. In this case also the body is accelerating. And what type of acceleration is this, student? These are uniform acceleration. Why? Because the velocity is increasing. The speed is increasing at a constant rate, at constant speed. So uniformly accelerated motion. Both this motion describes uniform acceleration. Now student, we have third case where the speed is constant 5, 5, 5, 5. With the passing time, the body hasn't changed its speed throughout its motion. So that's why for 0 also we have 5. For 1 also we have 5. At the end of a 2 second also our speed is 5. At the end of third second also our speed is 5. At the end of the fourth second also our speed is 5. So speed didn't change throughout the motion. That's why we got the graph straight line parallel to the horizontal axis. So here are the situations mentioned. Initially, in this case, initial velocity is 0. Acceleration is not equal to 0. Acceleration is positive. Student, when the speed of a body increases, we say the body is accelerating. If the speed is increasing, the acceleration will be given a positive sign. Here also acceleration is positive. Acceleration is not equal to 0. Initial velocity is 5. Here initial velocity was 0. Here initial velocity is 5. Now in this case, initial velocity is 5, but acceleration is 0. Why the acceleration is 0? Because the speed is neither increasing nor decreasing. So there is no acceleration involved. So acceleration is 0 in this case. Now let's see, student, one more case is there. This is the fourth case we have, where speed is 20, 15, 10, 5, 0. Speed is decreasing, student. As the time is passing, 0, 1, 2, 3, 4, the speed is decreasing. Let's try and plot this graph. Along the vertical axis, we have plotted speed, and the horizontal axis, we have the time. If I plot this graph, we'll get the graph like this. Now, students, this is also the case of acceleration. Why? Because the speed is decreasing in this case. And if you observe carefully, in this case also the speed is decreasing uniformly, because every 1 second the speed is decreasing at the rate of 5, 5, 5, 5. So this is also the case of acceleration, but because here speed is decreasing, so we will say it's a deceleration. When the speed is increasing, we will say acceleration. If the speed is decreasing, we'll say it's deceleration. As I mentioned, student, if the speed is increasing, acceleration will be given a positive sign, and if the acceleration is speed is decreasing, we'll give the acceleration sign negative. So if speed is increasing, acceleration will be positive. Speed is decreasing, acceleration will be negative. That's very important point. Okay, students, before we end today's this lecture, here are a set of questions to make our understanding more clear about this graph and their studies. Type of motion. Students, we have two different type of motions: distance time graph and velocity time graph or speed time graph. So here are the 4 distance time graph, and we have 4 velocity time graph or speed time graph. Now, students, if you are asked to describe the type of motion by this graph, what type of motion is described by this graph? So what is the answer? See, student, compare this graph. This is your velocity time graph, speed time graph, and this is your distance time graph. So before you answer any graphical question, you must see what type of graph is that. First, is that a distance time graph or a velocity time graph? So in this case, it's a distance time graph. Now, students, as the time passes, the body's position, the body has not covered any distance. As the time is passing, the body is not changing its position. That means the body is at rest. So this graph represents the body at rest. So answer is body is rest. Next comes, suppose, this distance time graph. Now, student, this is a straight line inclined to time axis. If you go back to distance time graph and see what does this distance time graph represents, dt graph, that's a uniform speed. So that means initially up to this time the body was in motion. The body was in motion and body was moving uniformly. Uniform speed. The body was moving at uniform speed. Now after this time, the body comes to rest. The body has stopped. So this is how we have to describe it. Now, students, this graph, what does this graph says? Distance time graph. Student, now see, from this point to this point, the graph is straight line inclined to time axis. Again, describing the uniform motion of a body, the body moving with a uniform speed. But now, student, the graph is moving downward. And as I mentioned, with the increasing time, the distance cannot decrease. So this part of the graph is not a real graph. This type of motion doesn't exist in real world. Next comes to this graph. See, does this graph represent any real situation, students? This graph is also not possible. Such type of motion doesn't exist. Now, why such type of motion doesn't exist, student? Now, suppose at this point, let's understand. At this point, if I draw one vertical line like this. Now, students, see, if I draw one vertical line, you can see at this point, you have 2 positions. One at this point, and at the same time, here it is. So is it possible for anything to be at two different positions at the same time, student? Not at all possible. So this graph also do not represents real situations. So that's all about the distance time graph, student. Now let's talk about velocity time graph, speed time graph or velocity time graph. In this case, velocity time graph, this two graph looks similar, but see student, this is distance time graph and this is velocity time graph. As I mentioned, before you answer any question, graphical question, you must see what type of graph is this. Is the distance time graph or velocity time graph? Now this is velocity time graph. Velocity time graph is horizontal time axis. It means the body is in motion in this example. The body was at rest. Here in this example, the body was at rest. But here in this case, the body is in motion. The body is moving with a constant speed. Throughout its motion, the body hasn't changed its speed. Neither the speed has increased nor the speed has decreased. So this represents uniform speed or constant speed. Now next comes to this. In this case, student, this is again a velocity time graph. This horizontal line indicates the body's motion is accelerated motion, uniformly accelerated motion. Uniformly accelerated motion. And now, after this time, the graph is horizontal. The graph is parallel to the time axis. It means after this time, the body's speed has become constant. Now, in this case also, velocity time graph, student, in this graph, in this velocity time graph, this part of the graph, which is a straight line inclined to time axis, indicates uniform acceleration. Body's speed is increasing, so body is in uniform acceleration. Now this part, from this time to this time, this graph is a straight line slope downward. So this part of the graph represents the body's speed is decreasing, means the body is under deceleration. So this part of the graph represents uniform acceleration, and this part of the graph represents uniform deceleration. From this point to this point, the speed was increasing. That's why the graph is upward. And from this point to this point, the speed is decreasing. So the graph slopes downward. So this part of the graph represents uniform deceleration, and this part of the graph represents uniform acceleration. Now, student, the last part of the graph, this graph again, if I draw one vertical line like this, at this point you can see the two speed will be there. This is one speed and this is one speed. Again, a student, this is not possible because at one point, at one time, a body cannot have a two different speed. So student, with that, we come to the end of this graph and graphical representation session. I hope you understood the different type of equations and a different type of a graph, distance time graph and velocity time graph, and its importance. So next lecture, we will discuss about the equations of motions and its derivations using all this graph.